Our next speaker is Pilpel, the president of Polystrand. And if I get it right, his title will be Life Cycle Assessment, a central element and tool for understanding the many aspects of sustainability. And
so good morning, everybody, both here and virtually. Thank you, Roberto. So as a backdrop for today's talk, let's talk a little bit about sustainability and circularity. Certainly you've heard those terms lately, and they've become certainly more present and discussed certainly in Washington in the infrastructure bill and all those types of subjects. So as we look at from a composite viewpoint in terms of recycling and sustainability of the products and long life, we start looking at the life cycle assessment of composites versus other materials. So that's something we're going to delve in today a little bit here. Got that. Okay. So just to outline some of the things we're going to talk about, little introduction to set the backdrop without just diving into LCA. Don't know how familiar everybody is, but I'm going to assume some of you have some experience, some not, and just try to connect dots here in terms of the key role that LCA plays. We'll go through some background that'll lead us to sustainability factors. There's more than you certainly heard a lot about carbon dioxide, greenhouse gases, but there's a lot more to the whole life cycle assessment story than the greenhouse gases. Certainly that's a key one, but we'll go through that, get to a point where we've got a chart that'll kind of put the life cycle assessment in the center and how that fits in with sustainability and fits in with the circular economy, which will ultimately need to go to in order to use all the resources and everything that we build these products with to return them and to build new products. And what does LCI look like? That is kind of the beginning point of developing an LCA. And as we talk about different acronyms, environmental product declaration and PCR rules, and there's a whole host of acronyms. So I just wanted to put that in perspective for you and connect some dots, and where we as engineers and civil engineers, mechanical engineers, where we can start to look at this whole life cycle assessment and use it as a tool as part of our engineering design. That's where we want to get to. And pathway to EPD. So we'll try to explain that, right? What all that means and what it fits, and summarize it at the end. And I left a couple of resources at the end of the talk. So if you want to go deeper into all the conversations about plastics recycling or textiles or food or global standards for recycled materials to be sent to different parts of the world, there's a whole community out there talking about this subject. And an LCA, again, plays an important part. So an introduction. What is green and what is sustainability? We could spend the next 2 days talking about these two things. I don't think we'd ever get to a consensus on what those things mean. So for the purpose of this presentation, I put some definitions down. The first one, John Bucell and I learned back in 2007 at a conference here at UMaine, was actually in Bar Harbor, if he remembers. And John and I've had these discussions, been working together for 25 years. What does green mean? You ask anybody and you'll get different answers. I've still got $100 in my wallet that I offer to anybody to give me the right answer. So we're going to cut to the chase here, and I'm going to give you the right answer right here. It's just a process of common sense. And that came out of a tract from that 2007 conference. Many people struggle with that. And one gentleman, first name was Wayne, answered the question, certainly for me. Let's not get involved in a lot of details on it. Let's look at a big picture view. If we just put some common sense to what we're doing and how we evaluate things, it's going to go a lot faster and we can move ahead and not get caught up in the terms and definitions. So again, for the next one, sustainability, again, we can spend a lot of time on that, but for the purposes of today in this paper, let's just minimize our overall impact from all aspects, being greenhouse gases, wasting water, using water properly, using all the resources we use properly, and think about how we're going to get them back in our design approach and our engineering approach, let's say for infrastructures. And then the next thing, just a little background, just to go along that common sense theme. If we look at where we are today in the US, we consume about 70% of the world's energy. A lot of BTUs there. 100 quadrillion is a big number. I can't quite figure out what that is. But if you look the way we've used fossil fuels in terms of what they expect or estimates we've seen on how much we have left, and the ranges, they're actually bigger ranges than this. But the long and the short of it to me is if you look at it from a common sense point, it took hundreds of millions of years to create the fossil fuels we're using today. And in a blink of an eye, we're going through those, okay? And let's compound our usage of that. If we look at the efficiencies of an internal combustion engines, which I love, right? I love the cars, but from a common sense standpoint, we've got low efficiency there, 25 to 40%. If we look at some data for power plants, be they oil, gas, or coal, those overall efficiencies are below 50%. So not only have we gone through pretty quickly and used those fossil fuels, we've used them with fairly inefficient systems. So from a common sense point, it would say we need to do something different with that. So the DOE in a report not too long ago estimated we're still going to be at 76%. I think there'd be a lot of debate with those that believe we can get to a lower percentage in the next 30, 40 years. So that one's up for debate, certainly. Certainly, as we use resources, we got to be more conscious how we use them, right? And then LCA will help you understand that and compare that, assuming you have the right life cycle inventory input data to put in there. So overview, we need to take a realistic approach to this. We're not going to solve this in 3 to 5 years. It's going to be a long-term journey to solve this. And as we know, there's a lot of talk about sustainability with greenhouse gases, but also, as Roberto said in his opening remarks, we need structural materials that have certain properties of long service life, durability, corrosion resistance. As Joe mentioned, there's all those factors would be important for a material we could use for the long term. And the reality is, from a composite standpoint, recycling composites is a challenge. Everything that makes them last long makes them difficult to recycle. But there is some horizons there we're going to talk about a little later in the presentation. And don't forget, at the get-go, as Joe talked about, composites are inherently sustainable from the standpoint that they will last a long time. They are resilient. They do stand up to corrosion, and they are lightweight. So in their use, those are all great attributes. We have to figure out kind of the rest of the story, how we can use them over and over again, which the industry is doing. As John explained in one of his last slides, ACMA is taking on a project to really look at this in depth and to understand it, and originally did take a look at LCI in 2012 and did a really great job of putting together a report that gave you LCI data, the life cycle inventory. That's the first step towards an LCA that can be peer reviewed under an ISO 14040 framework, management framework. So again, I want to help you connect the dots to some of this. And all of us can do LCAs. There's free software on the internet. You can start to get your feet wet doing that. But as we get into this, we'll see there are certain things for a environmental product declaration. You need a peer reviewed LCI, LCA in order to get you to meet the standards or the framework set up by ISO that'll give you the credibility that you have an LCA that'll be credible. So just some sustainability factors, right? Air is important to us. We breathe it. Greenhouse gases are a problem. It's something we can really understand that we need to do something about that, the CO2s. Water is also a basic necessity that we need, and we have less and less potable water, but you'd be surprised in an LCA analysis how much water we use as part of the manufacturing process. And we'll look at that as we look at an LCI later. Natural resources, once we take them out of the ground, it's tough to put them back. It took a long time for those things to grow and generate hundreds of millions of years. So we have to be very cognizant of how we use them and think about in our designs how we can extract them back out after that product is at the end of its life cycle. The energy we use, right? We use energy to make all these products, to transport them in the manufacturing process. That's all part of the LCA assessment of how we use those energy products. And efficiency, right? How efficient are the processes that we use to make that? So we make the best use of the resources. And one thing we've talked about a little bit, right, is time. And one thing that we certainly from a composite standpoint, we excel in, and that is a longer service life. And that'll have a significant impact on your life cycle assessment over time, right? The thought of a 100-year bridge, it makes a big difference when compared to a 70 or 50 year lifetime bridge made in steel. That has an impact on your LCA. And just a little bit about recycling horizons for composites, right? So I've got to look back 10 years, and again with my colleague John Bucell, what we thought about where we need to go when our own industry didn't want to talk about it or look at recycling composites, didn't think it was necessary, and certainly couldn't justify from a cost standpoint. If we could find those technologies, right, that could recycle composites and we could use them again, and that would be a great thing. So fast forward 10 years, there's been progress made on that, but we have some horizons ahead of us, 25 or 40 years in front of us. So a very significant thing that's happening, if we look out 40 years, is that technology on the resin side of a composite, there are epoxy systems now just starting to be commercialized that are specifically made to be unzipped. So if we talk about unzipping our composites and having that technology initially employed in those designs, in those structures, that 25, 30 years from now, when a wind blade wants to, when it comes out of service, we have a process to recycle it, bring back the resin monomers, bring it back to their raw materials, harvest out the fibers, the composite fibers, and start over. So that's kind of the long view horizon, but we do have technology. The first commercial sale of a recyclable wind blade by Siemens Gamesa was made this week. So that's kind of our end horizon, right? So now if we say that, okay, we can do that with wind blades, let's do it with boats. Let's do it with bridge. So if you got a 100-year bridge, great. We just increased the time, the life cycle of that bridge. And if we now employ these resin systems, when we get to the end, long after we're all gone in this room, they'll be able to use those resources again. So back to the sustainability definition for today. Let's do things today that'll have less impact on the future. Okay, so a chart here I've been developing the last 10 months, and it's actually gets a little distorted as I put more information in it, because so much has happened in the last 10 months in terms of critical mass and other forces besides LCA, LCI, which I put in the middle. We have the blue squares that make up all the different aspects that LCA, LCI, LCA will play a part, but eventually we want to get to that circular economy, right? So just going clockwise quickly, because we don't have a lot of time to go through everything. GWP, global warming potential. That's your greenhouse gas. And there's a whole system there to evaluate that and look towards what, net zero of that. And that's a very complicated subject in itself, right? To really attain a net zero. But there's a lot of activity there. There's a supply chain we need to get to a circular economy. And oh, by the way, now there's a global recycled standard, ISO, that if you're processing materials and you're going to recycle them, whether it's food, textiles, or ever, there's a standard that you have to meet in order to globally trade those recycled products, okay? There's the ESG. I'm sure you've heard about the ESG, environmental, social, and I put in there parentheses, corporate governance. There's a lot of activity at the corporate level to change their whole thinking and their philosophy, and putting sustainability very much at the top, where we have sustainability officers at most corporate institutions now. In there are carbon credits. We see a lot of movement from the investment community that want to invest in sustainable companies, be they startups or be they companies that are in deep into sustainability. And Wall Street's put a lot of pressure on large corporations as part of your portfolio. It's about your financial performance. It's about your sustainability performance. So let's continue on. Life cycle cost analysis. That's a big one, something we can look at certainly with this audience. And an important one, design and engineer for sustainability, right? That's something we got to think about, something we can do in terms of engineering the infrastructure and just our typical look at engineering, along with the structural analysis, do a life cycle assessment and make those compromises and decisions that include what happens to that product in 100 years. Most of us were never taught in our technical educations about recycling or sustainability. Make the best product for the least amount of money, most durable, do all those great things, but what happens at the end? That's not part of the system. That's something we got to change. So service life is important. The EPD and PCR, lots of acronyms there, all pile up into things that are on the table, you know, certainly being done by the European community and requirements, and certainly European Commission saying what those levels need to be it greenhouse gas or whatever. So there's a lot of pieces here. We can do something if we take a look at LCI, LCA, design and engineer for sustainability, long service life, and of course, we're going to have to look at the costs. So what does an LCI look like, right? It's not a three-headed monster. It's pretty simple. There are raw materials which make up a big part of your final LCA analysis, and the LCI data itself, the raw materials themselves, where they come from, how they get to you. Any manufacturing process in the beginning, whether you're building a girder or you're compression molding, that goes on, and there's energy requirements that come into that. And then there's the outputs, right? You're going to make a product that goes. You may have some useful byproduct that you can use off your process that possibly can be recycled and put back into the system. You may have several, but you also at the same time have air emissions, the greenhouse gases, and there's a whole laundry list of different gases that you could be producing that all make up that greenhouse gas effect. You have solid waste and we have water waste. And like I said before, you'd be amazed how much water we use in manufacturing. So let's take a look. This is an LCI data sheet out of the 2012 LCI report that ACMA did. So now we get into the weeds here and the nuts and bolts, and we're just looking at a compression molding process, right? If you're using that, it's not the raw materials, which is the largest part of the LCA and the LCI. That's the big part. That's where a lot of things happen. But just to take a simple part of it, compression molding, your compression molding apart, and this is based on a unit of 1,000 pounds. Okay, we could have done a pound, could have done 1,000 pounds. They used 1,000 pounds to put some kind of reality into it, right? I'm going to make a batch of 1,000 pounds of compression molded parts. It could be 1,000 pieces, could be 10 pieces. But in addition, here's your inputs, right? You're putting, these are all the material inputs that have come to that compression molding, right? And it gives you the pounds. And then at the bottom is the water, 53.5 gallons in a compression molding process to make that part. If you look at the raw materials, the same kind of LCA, you'll see much greater amounts of water for that processing. We only got 5% of potable water. So where are you going to get that water going forward that maybe isn't as clean, but could be used in your process? If we move on, now we get to energy, right? It's not just about the energy of the electric power that you heat up the mold with. It's about the transportation of the forklifts in the factory, how those materials got to your factory to put together. And then when you get to the FOB part, when you put that product on the dock, ready to be shipped, then you're basically at a gate. You've taken the raw materials, you've got all that LCA, LCI work, you've compression molded it, you've put it on the gate, but now what's next, right? That's going to go out into its service life. And what happens when that is over? Where does it go? We got to have to think that through so we can have a whole, that gets you to the circular economy, right? So the longer that thing is in service, that product, let's use a 100-year girder, if we can extend that, maybe that 100-year girder will go 150 years. We don't know that yet, right? Be nice to have that science behind it. Say, you know what, knowing what we know in 10 years from now, you know what, that bridge is going to go 150 years. But if we've also built in the end of a life story for it and recycle it, be able to recycle it, unzip it in the final analysis, we'll get the most out of those resources. So again, environmental emissions, if we look at all the atmospheric gases, right? It's not just CO2. It could be nitrogen, it could be methane, it could be styrene. We have VOCs in our thermoset processes typically. Those all add to those emissions. And then back to the solid waste. What do we do? On this particular product, we had 90 pounds went to landfill. So out of that 1,000 pounds, we had about 9% go to the landfill. So there's a target. How do we reduce that? Okay, I'll make this one. I won't go into a lot of details on this one, but just wanted to show you the steps. We can start doing LCI, right? You can do LCI on a software package to get a sense of it. There are companies out there and there are resources that you can do an accredited LCI, LCA, so that you can follow this pathway to, number one, a peer-reviewed LCA, right? If I do an LCA and John Bucell does an LCA, maybe we use different, let's say we use the same software, but if we use different assumptions, right? In terms of what I just showed you in the LCA, we're going to come out with two different results. So somewhere we need some body to look at them, body of experts to look at our two LCAs, LCI, LCAs, and put them in perspective in terms of being credible. Maybe John did a better job than I do. We do compete on certain things and when it comes to composites, but okay, he does a better job than I did. Why was his better than mine? What group accredits that? So when you look at the 100-year bridge beam, where do you get the credibility that said you did an LCA in a way that is credible, right? We need credibility for the LCA work we do. If I do it on a software and if I do it in a spreadsheet and I put it together, how do I know I have all those factors we looked at the LCI just to start with before we go to the LCA? But if I want to go further and I want to get that environmental product declaration so I can sell a beam made of Maine to the Netherlands, I've got to have an EPD. I've got to declare basically what my environmental impact is on through that LCA. And that has to go through these number of steps without going into the details. But that credibility of the LCI, LCA work you do is the basis for comparison. If we want to compare to steel, how do we compare to steel? Well, again, we can go back to some basic software, go through that. And I'm running out of time, so we're going to make this, I have to wrap this up. But you can see it gets fairly complex. But again, we can start with LCI, LCA, make some analysis, make some judgments in comparison to our structural analysis and how we should proceed from a sustainability and circularity standpoint. Okay, finish up here. Sustainability is about the next generations. Whatever we do today, it's going to affect the next generations in terms of resources and all the environmental impact. But sustainability is an opportunity for composites to grow, right? We know they're inherently sustainable. They last a long time, but sustainability and looking at circular economy can be an advantage for us to push that forward. Realistically, it's going to take time to transition to a sustainable and circular economy. It's not going to happen in a short time. And it should be a part of product design, right? LCA, LCI analysis should be part of it, of that process. And LCI, LCA is a tool. Recycling of composites long-term commitment. The industry has made that commitment now and is putting money towards that. And as we talked about those horizons, they're definitely out there. We just have to find the technology to basically incorporate it and make those things happen. But the technology and the horizons are there. There are many aspects of sustainability, right? As you saw in that chart, it's just not one thing. All of those are connected in general in some way. And it's time for us to think about, as we talked about a little bit, beyond the business case. We typically look at the business case, and I heard from the commissioner that it's all about the cost. How do I use those resources? I took a less better solution for a couple of bridges, but I got to do more bridges for now. That thinking we've got to change, right? So There's some resources here. If you really want to delve into some of the ESG and all that kind of not noise, but all the other things that are going on. There's such a live community out there, and there's so much information on a daily basis on all the things going on. But again, things we can do are related to design, and we can augment that design with LCI and LCA. Okay. Thank you very much.